Hi guys, today we're going to go over something called stoichiometry, and just pay close attention because you're going to have a lab that is going to be related to this next class. Okay, so let's talk about the objectives. So today what we're going to do is we're going to talk about mole ratios in a balanced chemical reaction. We're going to do some stoichiometry questions, and we're going to go over how to do them in detail. We're going to do some percent yield problems, and then next time we'll worry about limiting reagent problems or limiting reactants. So you don't have to worry about the last objective today. That's going to be next time. Okay, so the first thing that we're going to do is we're going to talk about something called mole ratio. So mole ratio is very similar to regular ratios that you would learn about in math class, except you're applying chemistry concepts to it. Okay. So before we start on anything, we have to talk about what stoichiometry is to begin with. So stoichiometry is when you are relating the amounts of reactants and products in a chemical reaction. So for instance, like if you are someone who bakes, right? So you would know if I add this much flour to this much eggs to this much whatever, I can make this many, you can make this many cakes or bread or whatever. So you know that if you use this many ingredients, you can make this many whatever you're making. Okay, so this is actually a concept that you guys use pretty often. You might not know that you're using it, but you do know that you are using it often in real life. So like if you need to make 2 cakes, then you know that I need to go get ingredients for 2 cakes. All right, so you're relating the amount of products and reactants. So stoichiometry is based on law of conservation of mass. Whatever you start off with, the mass, it might be a different substance at the end, but the masses should be the same, right? Because otherwise you would be breaking the law of conservation of mass. Okay, so the amount that you have in the beginning and the mass that you have at the end should be the same. Okay, so like here's another simple example. If you are making a grilled cheese sandwich, if you have 2 pieces of bread and you have 1 piece of cheese, you can make 1 grilled cheese sandwich, okay? You also know if I want to make 2 grilled cheese sandwiches, I need 4 pieces of bread and I need 2 pieces of cheese, right? So you're pretty much relating the amounts that you have in the reactant side and the amount that you will be producing. Okay, so you're just relating the left side and the right side of the reaction. You could also relate these two. Okay, so you could relate any 2 things in a chemical reaction, and that's what stoichiometry is. All right, so let's talk about what mole ratio is. Mole ratio is basically when you take the coefficients from a balanced chemical reaction and you put them into a ratio. Okay, so here's a chemical reaction and it's balanced, right? There's a 1 here that we just assume is there for in chemistry, right? So we don't have to write it in. So there's a 1 here, there's a 3, and there's a 2. So a mole ratio is when you are trying to compare any 2 things. So you could compare a reactant to a reactant. You could compare a reactant to a product. You could compare a product to a product. There's only 1 product here, but if there was another one, you could compare them using the mole ratio. So if I wanted to compare, or I wanted to write a mole ratio that relates the amount of nitrogen to hydrogen, then I know it's a 1:3 ratio. So I could write it into a fraction like this. For every 1 mole of nitrogen, I need 3 moles of hydrogen. Okay, so like 1 of these reacts with 3 of these. Okay, so that's pretty much what this is here. And this could be flipped, right? Depending on what the problem is asking, you need your units to cancel out. So you could flip this and it still works. So this is a conversion factor. So if you remember in the beginning of the year, we did conversion factors when we did dimensional analysis. So basically it's a fraction that changes the unit but doesn't change the amount that you have. So it's just a different representation of what you have, right? So whether you say it's 12 bagels or 1 dozen bagels, then it's the same thing essentially. You're just changing the representation. Okay, so you could also compare nitrogen with ammonia, right? So there's 1 of these for every 2 of these, so you could put that into a ratio as well. Okay, and you could also, this is not shown here, but you could compare this and this. Okay, so you could essentially compare any 2 things in a balanced chemical reaction, depending on what the problem is asking you. So the problem is going to give you information on one and ask you to find the other. Okay, so now we're going to get into these problems. Okay, so these are solving stoichiometry problems. All right, so when it comes to stoichiometry problems, the very first thing that you have to do is write a balanced chemical reaction. You can't do it without a balanced chemical reaction. If you don't balance your chemical reaction, you will get it wrong most of the time, unless all the coefficients are 1 and you got very lucky, or the coefficients are the same, you got very lucky, but 99% of the time you're going to get it wrong. Okay, so make sure that you are going to balance the chemical reaction. All right, so bear with me while I go through this flow chart. Okay, so it might look a little bit complicated at first, but we're going to do a few examples and then we're going to try to clear it up as much as we can. Okay, so you might look like this guy in the beginning, but hopefully after we do a few problems, you're going to get the hang of it. All right, so before we start, I'm going to be referring to A and B through this lesson. So just know that A is whatever is given in the problem, and B is whatever you are trying to calculate. Okay, so A is given in the problem, B is what you're solving for. Okay, so usually you'll be given mass of A. Okay, some mass of some substance within a chemical reaction. So the first thing that you need to do is you need to go from mass of A to moles of A. Okay, whatever A is. We know from previous lessons that we do that using the molar mass of A. And we know that molar mass comes from the periodic table, right? So you look up whatever A is made out of, right? So if it's H2O, you would do 2 H's, 1 O. You add up all the masses from the periodic table, and that's molar mass, okay? And it's grams per mole. Once you go from mass to moles, then that's where the mole ratio comes in. Okay, so mole ratio is what we did in the last 2 slides ago or something like that, where you have a ratio that is derived from the balanced chemical reaction. Okay, so this comes from the balanced chemical reaction. So this is new. Okay, this is old. We've done this already. This right here is new. Okay, so if you do that, if you use the mole ratio, you are converting from moles of whatever is given in the problem to the moles of whatever you are solving for. Okay? Once you do that, then if the problem asks for mass, then you're going to use molar mass of, this is a typo, I missed that. This should say B right here. Okay, so I'll fix that one before I post these notes, but it should say B. So once you go from moles of B to mass of B using the molar mass of B. Okay, so just keep in mind this right here is a typo that I missed. Okay. All right, so let's look at this problem here. I wrote on the bottom, if you could see in red, grams of A to moles of A to moles of B to grams of B. That's just me reminding you of the path that you're going to be taking, and every arrow represents a parenthesis. Okay, so this means that this is a 3-step problem. There's 3 arrows, so there should be 3 parentheses. A is what's given, B is what you're trying to calculate. Now it says what mass of chlorine, okay, so right away you should know that we are comparing chlorine to something, does the decomposition of 64 grams of gold 3 chloride produce. Okay, so this is what's given. Okay, so this right here would be A, and this is what we're looking for, so this would be B. Okay, so this is A, and that's B right there. Okay, so let's go through the steps of solving this. All right, so the very first thing that you need to do is balance a chemical reaction. So you're going to write the balanced chemical reaction here. The red right here, the red numbers are your coefficients, and the coefficients are going to be used for the mole ratio. Okay, so the second step is you convert from grams to moles using molar mass. Okay, so right here, 64 is what the problem gave us, and then this right here is from the periodic table. Now, grams is on top here, therefore grams must be on the bottom here. Okay, and remember that molar mass is grams per mole. So it's always, molar mass is always grams paired up with 1 mole, always. Okay, so this should always be 1 mole. If you have molar mass, it should always be 1 mole. Okay, just because there's a 2 here does not mean you're going to put a 2 there. Molar mass is always paired with 1 mole. Okay, that is a very common mistake that I see all the time, where people will take this 2 right here and try to fit it in here. Just remember, molar mass is something that has, it's like kind of like miles per hour. Miles per hour is miles per 1 hour. So grams per mole is grams per 1 mole. Okay, it's essentially the same thing. All right, so then now you're going to use mole ratio. So this is where the new stuff comes in. So you're going to use mole ratio. Now we're comparing this right here with this right here. Okay, so we have a 2 and a 3. So now you need to figure out where the 2 and the 3 go. So if you have moles of the gold 3 chloride here, then you need to put this on the bottom, right? They need to be across from each other so they cancel out. So this is what's going to end up looking like. Okay, so this is the first step, and this right here is the second step. So this represents the first arrow, this represents the second arrow. All right, so these are across from each other, so they canceled out. All right, so you do not want to flip this mole ratio, otherwise you will get it wrong. Things won't cancel out, your unit won't make sense, so make sure that you are being organized, okay? Make sure that you're organized, because it's very, very important in stoichiometry. All right, so then the fourth step is you're going to convert from moles of chlorine to grams of chlorine. So that's just molar mass again. So moles of chlorine is on the top here. So on the next part, moles of chlorine should be on the bottom. Again, this is molar mass. Molar mass should always be paired up with 1 mole because it's grams per mole. Okay, so the numbers that are not 1 mole are in the middle. Okay, this is the only place that it's allowed to be not 1. Any number other than 1. Here must be 1. Here must be 1 mole. Okay, don't mess that up. All right, so then your final answer would be 22.4 grams of chlorine. Now make sure that you're using the calculator correctly, because I feel like a lot of people mess this up. Make sure that you do 1 parenthesis at a time. So you can do 64 times 1 divided by this times this divided by this times this divided by this. A lot of people do this times this times this times this divided by this times this times this, and that will give you the wrong answer. Okay, so to go 1 parenthesis at a time. This times this divided by the bottom times the top divided by the bottom times the top divided by the bottom. Okay, so let's go over the process one more time. You're going to convert from the mass of the substance that you're given to its moles using its molar mass. Then you are going to use mole ratio, and the ratio should include the substance that you are given in the problem and the substance you are trying to calculate for in the problem. Okay, so that's your mole ratio. You're going to align things properly so that they could cancel out. And then you're going to convert again from moles to grams. So essentially, your problem should look like this. Okay, it should always look like this, where you have grams of something, whatever is given, its molar mass, the mole ratio of whatever you are trying to find, it paired up with whatever you're trying to find, and then the molar mass of whatever you're trying to find. Okay? So that's the path that you should always be taking. All right, so let's do a problem so that we make sure that we know what we're doing. So this problem says you have an unbalanced chemical reaction right here. If you have 350.6 grams of aluminum reacts with excess oxygen. Basically, what it means by excess oxygen, it means you have unlimited amount of oxygen. So for instance, if I tell you I need you to bake a cake and I have 2 eggs, but I have unlimited flour, then you don't care about the flour. You're only going to really focus on the eggs because that's the one that's going to determine how many cakes you're going to make. Okay? How many grams of aluminum oxide will form? Okay. So let's write this out. Okay. So the first thing that you need to do is you need to write a balanced chemical reaction. So let's do that. Why are you not moving? Hello. Lovely. Whoops. All right. So you have aluminum plus oxygen yields aluminum oxide. Okay, so if you were to balance this, you would have 4, 3, 2. Let me grab my notebook. All right, so you're gonna have 4, 3, and 2. All right, so those numbers are the ones that you are going to be using for your mole ratio. All right, so let's start with the number that is given in the problem. The problem gives us this value right here. All right, so right here, let's write it out. We have 350.6 grams of aluminum, right? Yeah. Okay, so the first thing that we want to do, so I'm going to write out the parentheses just so I could give myself a good amount of space. Okay. So I know this is a 3-step problem, so I'm just going to write out the 3 steps. Okay, so the first thing that we're going to do is we're going to convert from grams of aluminum to moles. Grams is on the top here, so it needs to be on the bottom. So I'm going to do 1 mole of aluminum for every, what is the molar mass? 26.98 grams of aluminum. Okay, so if I did this correctly, I would have my units canceling out, and I would just be left with this unit right here. Now, I have moles of aluminum on top, which means I need moles of aluminum on the bottom, right? So that they could cancel out. So if I look at my balanced chemical reaction, it tells me that there are 4. Okay, so that I just got from right there. And if I were to look at, let me see. What am I trying to get? I'm trying to find the product, right? So aluminum oxide. So I'm gonna get this 2 right here. So 2 moles of aluminum oxide. So this cancels out with this. And now I need to use molar mass to convert to grams. So 1 aluminum oxide, and the molar mass is 101.96 grams of aluminum oxide. And then my answer is 661.3 grams of aluminum oxide. Okay, so that's your final answer. Okay, and let's get rid of that. And all right, so just a quick reminder, I just want to let you guys know that there's another assignment on Canvas, and this assignment on Canvas is just a few questions, a few math questions, just to make sure that you understand the concept. Think of it as kind of like exit tickets. So I need to make sure that you guys understand how to do the math for this. Okay, so if you have any questions, please let me know. You could just go onto Canvas and send me a message on there. Okay, if you are honors chem, then you are still here. So you are going to now determine the percent yield for a chemical reaction. Okay, now the reason why we have something called percent yield is because we live in a world that is not perfect. So along the way, when you're doing a lab, you're gonna make a lot of mistakes. Things are gonna splatter. You're gonna have reactants stuck to whatever container they're in. You could have contaminants. There's like a lot of different things that could happen that will not give you the amount that you are expecting to get in a chemical reaction in a lab. Okay, so there's just a lot of things that could possibly go wrong due to human error or due to like error of your equipment or whatever. So you're not always going to get what you expect in a lab. You want to get close though. If you want to get somewhat close. Okay, so percent yield is pretty much a ratio of what you actually get divided by what you should have gotten. Okay, so there's two components to it. There's a theoretical yield and there's actual yield. So theoretical yield is what you would get in a perfect world. Okay, so if everything went perfectly, absolutely perfectly, which is very unlikely, that's what you would expect to get. Okay, so this is the calculated number. So this is the number that you calculated. All right, so you calculated this, and in a perfect world, you would get this in a lab, but you don't. Okay, the actual yield is what you would actually get in lab. So you went to the lab, you ran the experiment, and then at the end, you have your actual yield. Okay, so obviously we don't have access to a lab, so this is information that I would always be giving to you. Okay, so I'll give you what the actual yield is. So I'll just give you some hypothetical problem. A lot of chem problems will give you just like a hypothetical, like, oh, someone did this experiment and this is what they got. So the actual yield should always be given to you. Okay, it should always be given to you. If you're in a lab, it's what you get in a lab. Okay, theoretical yield is what you calculate. Okay, so calculated, and this is what you get in a lab, or it should be given to you. Okay, so it's actual yield divided by theoretical yield times 100. Okay, it's very simple. You just have to remember, what to put on top, what to put on the bottom, and that's pretty much it. Okay, if you usually will not get 100% yield, so that's normal. All right, so let's do a sample problem really quick. Sorry if this looks really busy. I forgot to put animation on this page, but on the slide. So what is the percent yield if 3.74 grams of copper is produced when 1.87 grams of aluminum is reacted with excess copper 2 sulfate? Remember, now if it says excess anything, ignore it. Doesn't matter. Who cares? It's just you have unlimited amount of it. All right. So now you have two numbers. You have two numbers in the problem. So now you're going to get confused, but don't get confused. So the number that is a product value is your actual. Okay, so pretty much what they're saying is like if you went into a lab and this is what you got, 3.74. So if you have a value for a product, okay, if you have a value for a product, that's your actual. So what they're telling you is they ran the lab and they got 3.74 grams of copper. Okay, so this is your actual. Don't touch it till the end, leave it alone. They're telling you that 1.87 grams of aluminum reacted. Okay, so this is what we're gonna be working with right here. Okay, so this is your actual because they're telling you this is the product. Okay, so the product is, percent yield should be a product, grams of a product divided by grams of the product. Okay, so like you percent yield equation should not have values of reactants in it. It should always be products. So you have 3.74 grams of copper. And just leave it. All right, so 1.87 grams of aluminum. So what you want to do now is you want to do a stoichiometry problem where you set up from the grams of aluminum to find out how many grams of copper would be produced in a perfect world. Okay, that's your theoretical yield. Why do you have to set up a problem from aluminum to copper? Because the problem gave you mass of copper. When you do percent yield, the grams, it should be grams of copper divided by grams of copper. Okay, you can't have like grams of copper divided by grams of aluminum sulfate. All right, so the unit for the top has to be exactly the same as the unit on the bottom. Okay, so you can't compare apples and oranges. You have to compare the two same products. You have to compare the same product top and bottom. All right, so now you're gonna set up a stoichiometry problem like we did in the previous slides, and you're gonna go from aluminum to copper. You set it up and you get 6.60 grams. This is your calculated value, which means it's your theoretical, so that goes on the bottom here. And then this value was given in the problem here, so that goes on the top, and then times 100, and then you get yourself your percent yield. Okay, so let's do this problem. All right, so this is the same problem that we did previously. So if you have your answer from the last problem, you don't have to redo this. All right, so like from the last problem, we said that we produced 661.3 grams of aluminum oxide. Okay, so this is the same problem, I just added to it. So this is what we solved for. Since this is what we solved for, this is your theoretical. Okay, that's your theoretical. Your actual is right here, it's given in the problem. Okay, it's produced in a lab. So what you're gonna do is 559.3 grams divided by 661.3 grams times 100, and then you get 84.5%, and that is your percent yield. Now this is grams of aluminum oxide divided by grams of aluminum oxide. Remember, the unit has to be exactly the same on the top and the bottom. Okay, if it's not, then you did something wrong. Okay, thank you, all of you. If you made it this far, well, you kind of have to make it this far. But if you have any questions, please send me a message on Canvas, because if you send it to my email, it gets lost with a lot of different emails. So I just want to make sure that I get back to you on time. So make sure that you just send it to me through Canvas. Otherwise, you know, I'm going to be a lot less helpful. All right, so good luck with everything. Bye.